Professional programmers often prefer less explicit type annotations, but beginners learning Rust may benefit from being more explicit, even though the compiler can infer types. Let's examine a program from Shesh's blog, Beginner's Guide to Error Handling in Rust. You can find the link to the blog here. This is the code from the blog. I will remove the unwrap function for now. The code reads the cargo.toml file into a variable named content and then prints the variable. The code compiled successfully, and the variable content contains a string wrapped in the OK variant. When we change the file name, for example, in a Linux system, this is considered a different name. Executing the code results in the error variant with an error message. It is evident that the variable content is of the result type with the string wrapped in the OK variant. The question arises, what is wrapped in the error variant? Apparently, the code failed to compile. One way to figure out the type of error wrapped inside the error variant is to use Visual Studio Code. After removing erroneous annotations, run Visual Studio Code. This is the correct type annotation. It doesn't make sense to define a variable that we don't intend to use. When operating on the variable content in Rust, you need to write code to handle two different situations. The Rust programming language prioritizes memory safety and performance. It offers option and result types to handle null or error values effectively. If you are certain that the error or null is impossible logically, and you have only one scenario to work with, Rust provides the unwrap function to unwrap the value wrapped in OK or sum. If the unwrap function tries to unwrap an error variant, the program panics. In the following example, we will create a function that converts a string to an integer and returns double the value. We will test the function by passing a string slice to it. The program will panic if the error variant is encountered. Now, we need a function that returns the value wrapped in the result type. First, the input is parsed. Then it is determined what to return. If the OK variant is present, we double the value, wrap it, and return the variant. Otherwise, we return the error variant. We face the same issue. What is the wrapped type inside the error variant? This time, we let the compiler figure it out by causing an error. The code is now functioning correctly. We will remove the bar function. As mentioned earlier, the design of the result enum ensures code safety. We need to extract the value if the OK variant is present. Here is an alternative method to extract the value enclosed in the OK variant.